Okay, well this is our final look at solving percent problems. We're doing this type of thing over 3 parts. This is part 3. Our objective in this video, we want to solve percentage problems using the percent proportion. As you'll recall in part 2, we solved percentage problems using the percent equation. That's one method. This time we're going to look at a second method using the percent or percentage proportion. Okay, as we like to do, as I like to do, I guess, I like to, kind of give you a sense of what we already know that's going to be applicable for this video. So what do we know? We know 2 things. We know that percent problems involve 3 quantities. In a percent problem, you have the portion or the part, you have the base or the whole, and you have the rate or the percent. And in percent problems, we're given 2 of these, and we're solving for the third. Okay, the second thing we know is that when we have 2 ratios or fractions that are equal, they form a proportion. Okay, so we're solving percent problems using the percentage proportion, so that this comes into play. The cross products of any proportion are equal, and we're going to make use of that to solve these problems. Okay, let's take a look at what the percentage proportion is. The percentage proportion tells us that the portion over the base, in other words, the part over the whole, is equal to the percent or the rate over 100. Now, the key difference between this using the percent proportion and using the percent formula is that we're factoring the 100 in when we do our math. So the number above the 100 is simply the number part of the percentage. Okay, so we're not going to have to do any decimal moving in this case. We're simply going to put the number up here because we know that the number as a percent is equal to the same number over 100. Okay, so again, because the 100 is included in our math, R is the number part of the rate or the percent. Let's take a look at some examples that'll help this make sense. Okay, what is 35% of 60? All right, we still need the rate. We still need to identify the rate, the base, and the portion. Well, the rate's right here. The rate is 35%. But as I said up here, because we know that percent means we can drop the percent sign and put in 100 as a denominator. Since we have the 100 in our equation, our proportion, we're simply going to be focused on the number part of the rate. So the 35 is what we're looking for in our proportion. Okay, what is 60? Well, it looks like 60 follows the preposition of, so that tells us 60 is the base. And in this case, the unknown it precedes the word is, or the portion precedes the word is, and that's our unknown. We don't know what is, and we'll call that X. Okay, so again, we have to have 2 of these, and 2 of these we have to know, and 1 of these is an unknown, and we're going to solve for the unknown. Okay, so our percent proportion tells us portion over base is equal to rate over 100, and again, the rate does not have the percent sign because we factored 100 into the equation. I'm going to go over here to the right. Our portion is our X. Our base is 60, so I'm substituting into my proportion. Our rate is 35, and again, there's no decimal, there's no decimal movement because I'm factoring in the 100 right there. Okay, so these 2 fractions form a proportion. Therefore, we know their cross products are equal. So the left side is 35 times 60, and the right side is 100 times X. Okay, I'm going to get my calculator out, but I'll just do it on the side here. 35 times 60, 35 times 60, I get 2,100. So the left side is 2,100. The right side is 100 times X. We're trying to solve for x. It's multiplied by 100, so we'll divide by 100, both sides. 100 divided by 100 is 1. 1 times x is x. And 2100 divided by 100 is 21. Okay, so what is 35% of 60? Turns out 21. 21 is 35% of 60. So 21 cookies is 35% of 60 cookies, if you will. Okay, example 2, and I've already written them out, maybe be a little bit quicker. 70% of what number is 210? Okay, they have the rate, the base, and the portion. Okay, my rate is the percent, so my rate is 70%. And again, because we're using the percent proportion, we're going to focus on the number part of that, before the symbol, the 70. Okay, of what number? The preposition of is normally followed by the base, and we don't know what it is. So our base in this problem is our unknown. So we'll call that an x, representing an unknown. Is 210? The verb is often followed, sometimes preceded by the portion or the part. So this is 210. Okay, our percent proportion tells us, our percentage proportion tells us portion over base is equal to the rate, the number portion, over 100. I'll come over here. P, we know the portion is 210. The base is an unknown, so an x goes in for the base. And we know that 100 is always in the percentage or the rate ratio. And because we factored in the 100, we just need the number portion, not the symbol. No decimal movement, we just put a 70. 70% is the same as 70 over 100. Okay, two fractions or two ratios that are equal. We know their cross products are equal. So this is 70 times x is equal to 210 times 100. Okay, so let's do the math on the right side. 210 times 100, I think, is 21,000. Let's see, 2 zeros. Yes, I need 3 zeros. To solve for x, I'll divide both sides by 70. 70 divided by 70 is 1. 1 times x is x. And I'm going to do this with a calculator off to the side here. 21,000 divided by 70. I come up with 300. Okay, so 70% of 300 is 210. So using my cookies example again, if I have 300 cookies, the base, the whole, and I eat 70% of them, that's a lot of cookies, I've eaten the portion, I've eaten 210 of them, hopefully over a month or something. Okay, last example of the simple ones, then we'll get into a couple of word problems. 72 is what percent of 480? Okay, we have the rate, we have the base, we have the portion. Okay, 72 is, well, in this case, the portion precedes the verb is, but that's the portion near the verb is, of 480, preposition of followed by the base, 480, and what percent, our rate is an unknown. And so we'll call that x. Okay, let's set ourselves up here. Portion over base is equal to rate over 100. All right, so this is our percent proportion. I'll come off to the right here. I know the portion is 72. I know the base is 480. I do not know the rate. That's an unknown, so I'll put the x here. And it's always over 100. Okay, this time I'm now solving for the percent. So I have two fractions that are equivalent. I know their cross products are equivalent. This is 480 times x is equal to 72 times 100. The left side is already ready to go. The right side I can do the multiplication. To solve for x, I divide both sides by 480 because I'm multiplying by 480. The inverse operation is to divide by 480. 480 divided by 480 is 1. 1 times x is x. I'll get my calculator out. 7200 divided by 480, and the answer is 15. Now remember again, what goes in and what comes out, the answer is actually 15%. I don't have to move a decimal around, so this tells me the answer is 15%. Because what is up here is the number portion. I just need to add the symbol on. So there's no decimal movement when you're using the 100 doing your math. So back to here, 72 is 15% of 480. Okay. Let's take a look at a couple of word problems and apply the same strategy. The same steps. Okay. Number 4. If a type of solder contains 55% tin, how many pounds of tin are needed to make 10 pounds of solder? Okay, so again, as we know, we have the rate, we have the base, we have the portion. We got to come up with what these are. The rate has the percent symbol, it's obviously very quick to find. 55% is our rate, but we're going to do this using the percent proportion. So we're going to be using the 55 because the 100 is going to be factored into our math. So the question is the 10 pounds of solder the base or the portion? Well, let's see here for a second. If a type of solder, we also have an of tin here, how many pounds of tin to make 10 pounds of solder? So lots of ofs in here. Okay, we want to find the amount of tin, and it looks like the solder contains 55% tin, so it looks like we want to make 10 pounds, and we want to make 10 pounds, so 10 must be our base. This is the whole. This is the amount we want to make. We want to make 10 pounds. And we want to know how many pounds, what part of our solder is going to be tin. So that's our proportion, that's our portion or our part. Whoops. So this is our unknown, which we're going to put in X for. So this one took a little bit more kind of working with it. Okay. We had to understand that our goal was to make a total of 10 pounds of something, and that our solder is made up of tin and probably some other metals or other chemicals. Okay, so portion over base equals rate over 100. I'm going to come off to the right because I probably don't have enough space going down on my paper, so I'm just going to go off to the right. Portion's the unknown. Our base is 10, and we want it's going to be 55%. We always know it's over 100. And we know that we're only using the number portion because we don't have to move the decimal because the 100 is included. And so here we are. We have formed a proportion. So we know the cross products are equal. So the left side says 55 times 10. The right side says 100 times x. Well, the left side is 550 when I multiply. Okay, I can divide both sides by 100 to solve for x. And I come up with x is equal to 550 divided by 100. I think that's 5.5, but I'm going to check it with my calculator. Indeed, that's 5.5. And I guess that should be pounds. So I'll come over to here. Whoops. Sorry about that. And the answer, I'll go over to here. So it's 5.5 pounds. Okay, so I need Let's see if this makes sense. I need 5.5 pounds of tin to make 10 pounds of solder. Well, that makes sense. Tin is used to make solder and, again, other things. And so that number should be smaller than this number, and indeed it is. Okay, one last example, which has a word in it that we're going to have to understand. If a 150 horsepower engine delivers only 150 horsepower to the driving wheels of a car, what is the efficiency of the engine? Okay, well, we're back to what we know. Rate, base, and portion. Okay. If you look at these two numbers, we'll notice that neither of these two numbers is a percent. So it's fairly obvious looking at these two, and since none of them is a percent, that the rate is what we don't know. Okay? So the rate is our unknown, which we'll call x. However, if you go look up the word efficiency, what is the efficiency? It'll tell you in the dictionary that the efficiency is the percentage of what's delivered divided by how much horsepower you have, is the efficiency. How efficient something is what it does, how well it does with the total amount of energy possible. How good is the part? You know, how the closer this number is to this number is more efficient. So you can look up this word and it'll tell you that this is the percent. But I looked at this number and realized, well, neither of these are percents. So I must be looking for a percent. And if I go look up the word efficiency, I'm told that's what it is. That's a percentage. So I know that's my unknown. Okay, if a 150 horsepower engine delivers only this much to the driving wheels of a car, well, this is the base, because this is the whole engine, and this is what it delivers. This is the whole amount of power involved. So that's the base. The whole amount of power is 150 horsepower. Okay, that's what the engine is. Its maximum is 150 horsepower. Delivering 105 horsepower, that's the portion that it's delivering to the driving wheels. Okay, so it's delivering part of what's available to the driving wheels. Other parts might go to heat. You may lose a little bit in heat, or you may lose a little bit in friction. The turning of some of the gears may take some of that away. But this is the portion, and that's the base. Okay, let's set it up. Portion over base is equal to the rate over 100. Again, I'll go off to the right just because I don't have quite enough space to go down. I'll make sure you can see it. Okay, I know the portion is 105 horsepower. I know the base is 150. I know I'm looking for the rate, and I always have 100 in the proportion or in this ratio. Let's see here. Now I have two fractions that are equivalent. I can cross multiply 150. Whoops. I put an X in there, didn't I? I've been using an X, so let's keep using an X. I could use the R if I wanted to, but I've been using the X, so I'll keep using the X. Okay, equals 105 times, boy, getting a little bit sloppy here at the end, times 100. Left side is fine, right side can be multiplied, and I think it's 10,500. Divide both sides by 150 to solve for x. 150 divided by 150 is 1. 1 times x is x, and I'll do this in my calculator. 10,500 divided by 150, I came up with 70. And I know, because 100 is involved in the percent proportion, that this is the percentage, 70%. So I know that this tells me 70%. I don't have to do put any decimals in there. I just need to add on the percentage sign. So the efficiency, this engine is 70% efficient. 100% efficient means that if you put out 150, you get 150. But this engine is 70% efficient. All right. We've now gone through a fair amount with percents. We did the percent. We've identified the portion, base, and rate. In the previous video, we used the percent formula, and in this video, we used the percent proportion. Either of those two works fine, and it probably gets down to a place where which one you prefer, or maybe which one you prefer for the example you're given. But all percent problems work just like that.